We have been solving the second exercise for quite some time now, and this is the last part, part F. So let's complete this today. For any real numbers x and y, box of x, which means greatest integer value of x, plus box of y plus box of x plus y is less than or equal to box of 2x plus box of 2y. This is how the solution starts, where we decompose x and y like this using greatest integer function. And we already know that we can. X equals its greatest integer value plus theta, where theta is non-negative, that means it's greater than or equal to 0 and less than 1. Similarly, y equals box y or its greatest integer value plus say phi, where phi lies between 0 and 1 in this manner. Actually, this theta is nothing but x minus box x. Similarly, phi is y minus box y. Now, further depending on where theta and phi really lie between 0 and 1, some cases arise. So, let's see those cases. This is case 1, where theta and phi, of course, they continue to be non-negative, but both of them are less than 1 divided by 2. And in this case, let's see what we get if we multiply both of these equations on both sides by 2. That of course will give us just this and this. 2x equals 2 box x plus 2 theta and 2y equals 2 box y plus 2 phi. But what's interesting is what we get from the inequalities. If we multiply throughout by 2, these become these. 0 less than or equal to 2 theta less than 1, because 2 times 1 over 2 is 1, and we also get this from this. 0 less than or equal to 2 phi less than 1. So now you look at this equation and these inequalities and compare them with this equation and these inequalities. From these, you conclude that the greatest integer value of 2x, box 2x is nothing but this, 2 times box x, because that other part lies between 0 and 1, just like this one. Did you see where it's coming from? It's coming from this form. Similarly, from this equation and these inequalities, we get that the box value of 2y is 2 times box y. Okay. Now let us add these two equations. That way we will get x plus y equal to box x plus box y plus theta plus phi. And let's also add these inequalities. 0 plus 0 is 0, less than or equal to theta plus phi, less than 1 over 2 plus 1 over 2 is 1. So again you look at this equation, and this part is greater than or equal to 0 and less than 1. And that tells us that the box value of x plus y is this, box x plus box y. And the consequence is this. So we considered this expression, we have to show that this is less than or equal to this plus this. Let's see what happens, what we get from this. So box x plus box y remains. Okay, that part remains for now. And in place of box x plus y, we have another box x plus box y. So 2 times box x plus 2 times box y. But 2 times box x is box 2x and 2 times box y is box 2y. So we wanted to show that this is less than or equal to this. So we are getting equality here. That means still whatever we want, we are getting in this case. Next we have case 2. Here theta is non-negative of course, and this is less than 1 over 2, just like case 1. But phi is greater than or equal to 1 over 2, and of course less than 1. Then what will happen? In this case, the exact same calculation will also be there for theta. That is still 2x equals 2 times box x plus 2 theta, which we obtain by multiplying the x equation on both sides by 2. And from these inequalities we again get these ones, 0 less than or equal to 2 theta less than 1, because we multiply this part throughout by 2. However, what do we do with y? Now something has to change. We still multiply the y equation on both sides by 2, but we do something else also. So just multiplying the equation by 2, we get as before 2y equals 2 box y plus 2y. But we add and subtract 1. Let's see what the effect is. Now, what are you going to get from these last two inequalities? If you multiply throughout by 2, you will get 1 less than or equal to 2 5 less than 2. And then if you subtract 1 from all the three terms, that give you these inequalities. 0 less than or equal to 2 5 minus 1 less than 1. So here again you are getting this type of inequalities. The only thing is that it's no longer 2 5, but it's 2 5 minus 1. So as before, the box value of 2x from this equation and these inequalities is still 2 times box x. However, from this new type of equation and these inequalities, the box value of 2y is this 2 times box y plus 1. Okay. And also we add the two equations, original equations for x and y, obtaining this x plus y equals box x plus box y plus theta plus phi. However, this time we are not immediately able to say anything about theta plus phi because of these asymmetric inequalities. Theta and phi do not satisfy the same inequalities. So at most what we can say is that yes, it is greater than or equal to 0 and less than 2, which anyway comes from the original inequalities. But now, because of this inability to say something definite, this case itself further gets subdivided into two sub-cases depending on where theta plus phi lies in this region, in this interval between 0 and 2. Subcase 1 is the easier one, where theta plus phi of course is greater than or equal to 0 but less than 1. Then also it's less than 2, but in particular it's less than 1. Then from this last equation and these inequalities, we get as before that the box value of x plus y equals box x plus box y. Alright. And this then further gives us these things. Again we consider box x plus box y plus box x plus y. And again because of this we get 2 times box x plus 2 times box y. However, now the situation has changed here because of y. 2 times box x is still box 2x, but box 2y is 2 times box y plus 1. So we need to add 1 extra, and because of that we get inequality because this is going to be larger. This part is, where is it? Here, box 2x, and this part is box 2y. So in this case and in this subcase, within this case, this is less than this, but still we are getting that inequality. Next we have subcase 2. This time however, theta plus phi is greater than or equal to 1, and of course they are less than 2 because individually each one of them is less than 1. Now we need to modify that equation for x plus y. Originally it's x plus y equal to box x plus box y plus theta plus phi, but we add and subtract 1. Okay, what shall we get because of this change? I mean, the equation fundamentally has not changed, it still remains that equation. But now from these three terms, 1, theta plus phi and 2, you can subtract 1, obtaining these other inequalities. 1 minus 1 is 0, this middle term becomes theta plus phi minus 1, and 2 minus 1 is 1. Now you look at this equation and these inequalities. From them, it follows that in this subcase, the box value of x plus y is this part, box x plus box y plus 1. Okay. And again we consider this box x plus box y plus box x plus y. Now in place of this, now we are going to get box x plus box y plus 1. But already there is box x plus box y, so you get 2 box x plus 2 box y plus 1. And we considered this part separately. And as we saw there, this part equals box 2y and this part equals box 2x. So again we are getting equality, but that is included in that inequality, less than or equal to. This is still less than or equal to this sum. And next we have case 3, where this time phi is less than 1 divided by 2, but theta is greater than or equal to 1 divided by 2. And in this case we do not have to do anything because it follows from case 2. You think yourself how. And finally we have case 4, where both theta and phi are greater than or equal to 1 divided by 2. And of course both of them are less than 1. Alright, so now what will happen? Now we need to change the original equations of x and y like this. 2x equals 2 box x plus 1 plus 2 theta minus 1, where from these inequalities we get this 0 less than or equal to 2 theta minus 1, which is less than 1. Similarly 2y equals 2 box y plus 1 plus 2 phi minus 1, where from these other inequalities we get this 0 is less than or equal to 2 phi minus 1, which is less than 1. And combining all these things, this is what we get. This time both box 2x and box 2y are respectively equal to 2 box x plus 1 and 2 box y plus 1. Alright, and then we again consider, just like the other cases, x plus y, which is box x plus box y plus theta plus phi, but this time because of the situation we add and subtract 1 here also. Alright, now you just simply add these inequalities. What will you get? 1 over 2 plus 1 over 2 is 1. 1 will be less than or equal to theta plus phi, which will be less than 1 plus 1, that is 2. So that means here we are getting the beginning of subcase 2, and that is why from that inequality, or from those inequalities, because there are 2, we further get this by subtracting 1 from all the terms. 0 less than or equal to theta plus phi minus 1, which is less than 1. So combining these inequalities and this equation, we get this. The box value of x plus y is this much. Box x plus box y plus 1. And now we go back to our main thing, that is box x plus box y plus box x plus y. Now in place of this, we are going to put this. So we get 2 times box x plus 2 times box y plus 1. However, a single 1 is not enough, because we need 1 here as well as here. So we need to add an extra 1, which creates this inequality. The original expression is less than this plus this. However, this is box 2x and this is box 2y. So in this case, this is less than this. That means also in particular less than or equal to. So we have covered all the cases, and this is where the solution to exercise 2 finally ends.